install the CPU and add its cooler. I'm using a Noctua NHL9X65 here, which I specifically requested from Noctua, as it's one of the few low-profile coolers that's going to be adequate enough for this build. Just like the graphics card, however, we will need to remove its fan to keep its profile as low as possible, and as I mentioned last time, I'll be showing you the cooling method this is replaced by in just a few moments. Now, it's a good idea to add the RAM at this point too, which in my case is 32GB of nice speedy XPG RAM from Adata. The motherboard can now be sat onto the PCB pillars that we added earlier, with the 3 leftmost screws being capped off with some dome nuts, while the other 6 can be clamped down by some much taller PCB pillars. These sit just about level with the top of the heatsink, and the reason for using them is that even though we've managed to fit most of our components within our 44mm of internal space, the CPU cooler, RAM and I/O shield are all still slightly too tall, so we will need to build a raised section specifically for this area. The GPU can now also be mounted in place with its riser cable, followed by the PSU and all its cables. This leads me on to the topic of airflow, which is a hugely important part of keeping these components cool. The plan here is to make a positive pressure scenario inside the table itself, with the only place the air can escape being through the heat sinks, taking away the hot air. This should work quite effectively, but we'll have to wait until later to test it out. We're going to achieve this positive pressure by using many 44mm sized fans, and I've again got Noctua to thank for these, as they've sent over not 10, not 20, but 40 fans for this project. The idea here is to glue as many of them together as will fit into the case, which for me is 17 for each side. During testing,